Okay, so welcome to this event. This is the Beaver and Stormwater event put on by Clark Conservation District. My name is Ashley Smithers. I work with Clark Conservation District as a resource specialist. A couple of things that we do is we are a non-regulatory agency that works with residents of Clark County, Washington, providing technical assistance and to encourage good stewardship of the environment. And we also put on a number of workshops and webinars like the one that you're joining us today. So if you want to check out any of our past webinars, we have some really cool ones about stormwater and amphibians. Please check out our website, clarkcd.org. After tonight's event, please look for the survey to let us know, or please take that survey to let us know how we're doing. And if you are watching the recording of this later on, then that's going to be down in the YouTube link down below. And then we'll also have a link to that survey on our website. So I have a poll that has come up, and this is just to let us know a little bit about you, and this is something we're going to share. So everyone can kind of see who's joining us tonight. I also wanted to mention that if you are interested on our website where you most likely registered for this event, you can download the slides if you'd like to go ahead and follow along with those slides. And with that, I want to get to the main event of the evening, Greg and his awesome, wonderful person that he is. So thank you, Greg, so much for presenting today, and we're really looking forward to hearing all about that. I'm going to go ahead and let you all know who you are. So.
All right. Thank you very much, Ashley.
Uh-oh. It's not showing. So I will go ahead and, can you see that? The poll, Greg?
I do see the poll.
Okay, can you see the results?
Let's see. Yep, I've got the results.
Okay, excellent. Take it away.
All right, great. Well, my name is Greg Lewallen. I had the pleasure of meeting Ashley during my master's at Pollutant State University. We both worked with the venerable, the legend, Dr. Joseph Mazer. And after that, I had the opportunity to spend 3 years researching beaver up in Canada, in southern Alberta. And now I'm really excited to be here with all of you talking about beavers and stormwater. And taking a look at this poll here, it looks like we have a lot of students joining us, some government agency folks, we've got nonprofit folks. It's a pretty even mix. The majority of people are just members of the general public, just under half. So this is wonderful. And it looks like just over half of everybody loves beavers emphatically. So that's good. We're at 54%. Could be worse. This is wonderful. Because of this variety in participants, there's going to be a lot of information that is review for some people. Hopefully there's a lot of information that's new to everybody. I didn't create anything new here, but I hope to present some of the most recent research and just continue this conversation about using beavers to help manage stormwater. If I do not describe something well or leave something out, feel free to contact me via my email right there on the screen. You can call me. I'm happy to get a cup of coffee. It's hard during these times with COVID, but we can continue this discussion into the future. Okay, diving right in. Today we're going to talk about beaver and the role that beaver play in our stream ecosystems very briefly. Then we're going to discuss some of the research out there that backs up why we are thinking about using beaver to manage stormwater and large flow events in both wildland and urban areas. And then at the end, I'd like to briefly mention how we can start thinking about designing projects, whether they're restoration projects or stormwater infrastructure, anticipating beaver to be a part of those projects. Okay, diving right in. The North American beaver, a pretty incredible animal. It's the second largest rodent on the planet, second only to the capybara of South America. There are two species of beaver that live on the planet. They live in the Northern Hemisphere, the North American beaver and the Eurasian beaver. I think we all generally know the story by now that beavers were almost completely wiped out for a fashion trend. They were turned into hats, unfortunately. But the good news is that they've made a comeback, and they had now returned to occupy almost the entirety of their former range in both North America and Eurasia. The North American population is doing a little bit better than the Eurasian population. In the 1930s, wildland managers looked around and realized to their horror that perhaps beaver had gone extinct on the landscape, like I mentioned. With a significant effort in changing legislation and also occasionally dropping beavers from airplanes to seed them in wildland environments, the beaver have managed to come back. And still today, we are doing beaver translocations on the landscape. We're not dropping them out of airplanes anymore, but we are still moving beaver around. So why this significant effort for this one animal? Well, it's because beaver are special. They're considered an ecosystem engineer, or an animal that actively modifies its habitat to create and maintain a preferred niche or habitat. And in doing that, beaver also create habitat for a variety of other species. That is why beaver are considered a keystone species and an ecosystem engineer. Now, when we're talking about beaver, we're usually talking about a beaver colony or a family. Beaver colonies consist of the adult breeding pair, kits of the year, 1-year-olds, and by the time beavers reach 2 years of age, they have gained enough skills to be able to think about dispersing out of the natal pond to colonize habitat of their own. When beavers are out manipulating the environment, they're using these main tools. Their teeth are a primary tool. Beaver or rodents' incisors grow continuously for their entire lives. So that's why beavers must always chew. They have to continually chew vegetation to shorten the length of their incisors, and by chewing, they are also sharpening those teeth. The other tools are their very dexterous forelimbs. They use these to manipulate and move a lot of very heavy resources and material around on the landscape. Those resources are primarily food and construction resources. During the winter months, they're after woody vegetation. Their favorite woody vegetation by far are trembling aspen, cottonwood, and willow species. Beavers' diets adjust seasonally, however. So during the warm summer months, they switch from woody vegetation and are eating primarily herbaceous vegetation, leaves and grasses, things like this. Beaver are considered choosy generalist herbivores and operate using a central point foraging strategy, or one in which they radiate out from their pond and start to gather preferred food species first. Beavers dig extensive canal networks throughout their territory. This helps them access food resources that are farther away from the center of their pond. I love this research by Hood and Larson from 2014 that shows how beaver increase the connectivity on the landscape. They do this by digging these canals, and to me, these images look like neurons with dendrites radiating out from the central nucleus. Really interesting stuff. But as I mentioned, they will use these canals to access food resources that are farther away. They will then float those food resources back on the canals to the center of the pond, saving energy rather than dragging them across the landscape. Once they get these food resources to the pond, they'll store them in a cache on the bottom of the pond. These food caches are very important in northern latitudes where ponds freeze. Beavers do not hibernate, so they rely on this food cache to subsist over those winter months. They're not just eating these resources, they're also using them as construction material. One thing they build are lodges. They make 3 types of lodges. The first is the iconic water lodge. I think this is what we all think about when we think about a beaver lodge. It is made of mud, wood, and stones, and water lodges are completely surrounded by water. They have multiple entrances that are always submerged, leaving the interior high and dry and nice and cozy. The second type of lodge is a bank lodge. It's essentially the same thing as a water lodge, except for it's on the bank. And then the third type is a bank den. This is a burrow that beaver dig underneath the bank of streams, ponds, and lakes to create a nest above the water line in the bank. So the one common factor with all of these lodges are that the entrances must always be submerged beneath the water line. One way they do that is they build beaver dams. Dams come in all shapes and sizes, and they're made of the same material as the lodges: wood, mud, stones, and leaves and herbaceous material. They range from very small dams to really large structures, channel spanning structures on the landscape. Beaver build dams for multiple reasons, but some of the main reasons are to maintain those water levels, keep the burrow entrances submerged, to create deep water to escape from predation, and to keep ponds from freezing in the wintertime. By flooding upland environments, they also extend their foraging area and then can float their resources around their territory, saving energy. Beaver don't always build dams. Sometimes if they have deep enough water, they will not build dams, and instead they'll just live in burrows and lodges, eating vegetation. But when they do build dams, they can build anywhere from 1 to several, 10, 12 dams, often in series on the landscape. They'll continue to build on these dams, extending them laterally all the way to the valley walls in some case. And so by building these dams, they're ponding significant amount of water on the landscape and effectively increasing riparian and wetland habitats. So there's a lot to talk about with beaver, but we're just going to mention these few primary behaviors that they manipulate on the landscape. And the first one is they dramatically affect the hydrology of catchments. They do this by building dams, ponding that water, and then forcing that water laterally towards those valley walls. That then allows for infiltration into the subsurface, recharging local aquifers, and rising local water tables. So we see increased groundwater recharge, and they also filter out some of that water, improving water quality. By building dams and slowing the velocity of water, those beaver ponds allow for suspended sediment in that water to deposit onto the pond bottom. Suspended sediments will also be deposited onto the floodplains adjacent to the dams. Beavers will additionally mobilize sediments by digging burrows and canals and dredging the pond bottom to add sediment to their dams, lodges, and scent mounds. Because of all of this activity with sediment, beavers also dramatically alter the geomorphology of catchments. When beaver move into an area, they will start to remove some of the vegetation and build some dams. This initiates ponding. It also starts to store water in the subsurface. Eventually, beaver will build more dams. We see more water storage in both the surface and the subsurface. They continue to vegetation, and sediment starts to accumulate in the pond. Over enough time, they may harvest all the vegetation in the area, which will cause them to then abandon that site. However, the dams can subsist on the landscape after beavers leave, allowing for some water storage and for them to continue to fill up with sediment. Over time, that pond may completely fill with sediment, creating more of a wet meadow type environment. While this is happening, the vegetation has a chance to grow back, and the beaver may eventually come back to this site far into the future and recolonize it. This continual cycle of colonization and abandonment is one reason why we posited the beaver meadow formation theory, that over geologic timescales, we start to see significant accumulation of sediments in our alluvial valleys. Additionally, this cycle of colonization and abandonment creates a disturbance mosaic of patches on the landscape, where before we had a homogeneous stretch of boreal forest, now we see more of a heterogeneous patches of habitat that are cycling through different successional ages. That is shown in some of this research that came out of Finland recently in 2020. And in this graph, we see years since beavers started occupying this site. And on the bottom, on the x-axis, we have different beaver sites through time. And if we look closely at one of these sites, we see that the blue bar indicates that the site was flooded, and a green bar indicates that it was not flooded or that the beavers abandoned this site. And we can see that over time, beavers will flood a site, they will abandon it, they'll come back later, flood it again, abandon it again. Some sites say flooded continuously, and some sites are flooded once and then left abandoned for many, many years. Okay, that was a rapid discussion about beaver, but some key takeaways are that beaver are a keystone species and ecological engineer. They are back in almost all of the waterways of North America, and they are dramatically altering the vegetation in stream catchments and also the hydrology and the geomorphology. And since beaver have been around for thousands of years, they have been effectively managing and maintaining our watersheds in North America. All right, now to the meat of this talk. Let's look at some research that helps back up why beavers are being considered to help manage stormwater and large flow events. When we're thinking about beaver impacting stormwater, we're really considering three main categories: water storage in both the surface and the subsurface, flow attenuation or reductions in peak flows, and water quality, not only in removing nutrients out of our streams, but also improving the temperature and removing sediment from these streams. So now I would like to look at some recent research that helps back up this idea why beavers are considered to be used for this task. We can look up into Canada at the Alberta floods of 2013. This was a major event, a 40-year event in southern Alberta. This image is of the civil peatland, and this paper is from my PhD advisor, Sherry Westbrook, and others, just came out in 2020. And this peatland, civil peatland, I had the pleasure of exploring for 3 summers in southern Alberta, and it's just a beautiful, beautiful site. It's huge. And we're going to look at 3 beaver ponds in particular at this site. The 3 ponds in question, they can store up to a maximum of 17,000 cubic meters of water. During the initial storm surge, they stored around 8,000 cubic meters of water. Now, one key factor in surface water storage during large flow events is the capacity of the ponds at the onset of the event. If the beaver ponds are already full when the rain starts to fall, they're not going to be able to store that much water. But if ponds are half full or empty, they are going to store a lot more water. And that was the case with these ponds. They weren't completely full. Now, the main storage of water in this site was in the groundwater. The water table here rose about 1/2 meter after the onset of the rains, and it quickly rose above the surface level. So this peatland essentially became a giant pond, and this peatland full of organic matter acted as a huge sponge, absorbing and storing that initial water to then slowly release it over time. The main question we have right now is how much groundwater is actually stored by beaver, and we don't have a good answer to that. So there's a lot of important research in the future, hopefully asking that question. Okay, so the beaver activity is storing some water in the landscape. What about flow attenuation? When we're talking about attenuating flows, we're talking about dampening the hydrograph. So here's a hydrograph where we have flow on the y-axis, time on the x. And in the stream without beaver, we would expect the hydrograph to act something like this black line, where we have a sharp increase, maximum flow, a rapid decrease back to baseline conditions. A stream with beaver in it, we think might have slightly higher baseline conditions. And at the onset of the rains, our rising limb is going to gradually increase, and we're going to have a lower maximum, and then we're going to have a longer falling limb back to baseline conditions. So is this actually what we see out on the landscape? We can use research from England, Puddock and others, 2017. This was an intensively managed grassland with no beavers in it. Well, after the beavers showed up, they made a beautiful mess of this site. They quickly built 13 dams, and this site was gauged above the beaver activity and below the beaver activity, allowing us to see how this site reacts to large flow events. So here we have a hydrograph at the top left, flow on the Y, time on the X, and this blue line indicates the gauge above the beaver activity. So this is how the stream is reacting to the rainfall without any beaver dams in it. And we can see that we have a sharp increase. We max out at about 0.11 cubic meters per second and a sharp decline. This red line indicates the gauge below the beaver activity, and we can see that those beaver dams had an impact. We see a gradual rise and a lower peak flow. Is this the case during all large events? This graph shows 4 large rain events, and in each case, the gauge below the beaver activity has a lower peak flow. So we are seeing flow attenuation here. The idea is that the beaver dams are like speed bumps. They're slowing that water down, spreading it laterally, and storing it in the subsurface. So we're increasing the residency time of water moving through this type of habitat. We can look at this graph in the lower right. This is a 1-to-1 graph showing the lag times of that water. Lag time is how much time it takes from peak rainfall to peak flow. Essentially, how long did it take for the water to get into the stream? On the Y, we have below beaver lag time, and on the X, we have above beaver lag time. 1-to-1 graphs are useful at comparing two variables to see how they differ. If these did not differ, we would expect the trend line to fall on this black dotted line. But we can see that the red trend line falls comfortably above that line from all of these large rain events, indicating that it takes much longer for the water to reach the lower gauge than the top gauge. So all of that beaver activity is slowing down that water. We are seeing increased residency times and increased lag times. So I mentioned that beaver create wetland and riparian habitat. We can look at these images on the bottom to see how that's happening. We see this beautiful mess, and the beavers are spreading that water laterally, forcing it around the dam to re-enter the stream down below. There's also an increase in hyperrheic exchange, or the interaction between surface and groundwater. So we see more mixing of that water. Up above, we can use this diagram to see how a stream without beaver has a relatively limited impact on the groundwater, whereas a stream with beaver has a much larger impact on the groundwater, so much so that it has elevated the local water table. So in this instance, where there's no beaver, the riparian vegetation roots do not have access to the water table unless it's raining, especially during dry summer months. Here, the riparian vegetation has access to that groundwater from that elevated water table, which allows for obligate wetland and riparian plant communities to establish. I think there's no better way to see that happening than when we look what happens to beaver sites in the face of fire. Fire is a major problem in the West these days, and this is from the Sharps Fire in Idaho, where it burned over 65,000 acres in 2018. This comes from Dr. Joseph Wheaton of Utah State. And we can see that this entire catchment was burnt to a crisp, except for the valley bottom, which was completely saturated from beaver activity. Emily Fairfax and others, 2019, also investigated beavers and fire. And they also found that some of the only vegetation that was left after major fires was adjacent and in beaver modified habitats. Now, these images, the beaver habitats do not act as a fire break. The fire is able to jump the stream, but maybe if the entire stream was modified by beaver, we would be able to see them break some of these fires, especially lower intensity fires. With forest fires, a major variable is soil moisture, and beaver habitat increases soil moisture. Okay, what about beavers and water quality? Are beavers helping to clean some of this water? Temperature is a major pollutant of concern in the West, especially in streams with anadromous fish populations. This research comes from Nick Ballas and others, 2016, and this image is showing pond depth. So we can see a series of beaver dams in the top. They're actually Beaver Dam Analogs, which are human-made beaver dams, but they mimic a naturally occurring beaver dam in both form and function. There are also natural beaver dams in this system, so we can just assume that this system would be reacting the same way if it was all natural dams. So the darker the color, the deeper the pond. Compare that to the lower reach, where we have almost no depth complexity. It's just a homogeneous stretch of stream. Well, how does that impact temperature? Beaver ponds stratify thermally. So we'll see warmer water on the surface, a sharp thermocline with cooler water at the bottom of the pond. They investigated how this higher complexity in terms of depth and channel geometry affected temperature. We can look at the lower graph here and see temperature on the Y, and then distance from the bottom of the site on the X. So we're moving upstream as we go from left to right on the graph. These gray bars are beaver dams, and after we cross the beaver dam, we see that temperature drops. It comes back up, but when we cross another beaver dam, it drops again. Compare that to the unimpounded reach, where there is no temperature change. In fact, it just stays warm up here all the time in the maximum temperature range. So we see lower maximum temperatures in the beaver modified area. Essentially what they found is that the beaver activity is increasing thermal complexity of this site. By having more complexity, there's more refuges for the fish to find during the hot times of the day, and during the cooler times they can then explore other parts of the stream. How about sediment? Are the beaver dams filtering sediment out of these streams? This research comes from Puddock and others, again out of England, that same group that we looked at earlier, and they found that those beaver dams and that intensively managed grassland do remove suspended sediments from that system. Where did all that sediment go? Well, it was retained in those 13 ponds. Approximately 400 cubic meters of sediment, or around 100 tons of sediment, was stored in those ponds. Sherry Westbrook and others, 2011, found that sediment isn't only stored in ponds, but also stored adjacent to the pond on the floodplain. During a large flow event in Colorado, a plume of sediment around 750 cubic meters was stored adjacent to the pond on the floodplain. Other elements of water quality are also affected by beaver. Beaver ponds are generally a little more acidic than other water, and they are also higher in carbon. Phosphate and nitrogen are major pollutants of concern. Eutrophication is a huge problem these days. And Lazar and others, 2015, found that on the east coast of the United States, in nitrogen-enriched watersheds, beaver activity removed up to 45% of the nitrate, primarily through denitrification of those systems. So that's a significant nitrogen reduction. Some key takeaways to consider here: beaver dams act as speed bumps. They are dissipating that storm energy, slowing the water down, storing it in the surface, but primarily in the groundwater. We're seeing decreases in peak flows, and we're also seeing improvements in water quality. So this is why we want to try using beavers to help mitigate some of the negative effects of stormwater. A really big question these days is, well, what about in urban areas? Do beavers do the same thing in regard to stormwater in urban areas? I think a question we need to ask first, though, is, are beaver even present in our urban areas? And the answer is yes, they are. Bailey and others, 2018, found that in the city of Seattle, within the city limits, all of the available beaver habitat was occupied by beaver. We don't always notice beaver in our urban areas because they're nocturnal, and as I mentioned, they don't always build dams. So sometimes they're just eating the vegetation and accessing the waterways without us noticing them. In regard to managing beavers in urban areas, I like to think of a kind of a two-track thought process. The first track is that, okay, the beavers are present, so we need to manage them. Traditionally, that was done with lethal management, but there's a lot of public interest in using non-lethal techniques. So if that's the case, we're going to manage these populations. We're going to be managing them using the existing infrastructure present. If we want to take that a step further, the beaver are present, we're going to manage them, but let's start designing infrastructure and let's start designing restoration projects, anticipating beaver to show up and be a part of that project. First, let's talk about the first track. The beaver are in our urban areas. How are they affecting stormwater, and how can we manage these populations? So let's look at some evidence of how they are impacting stormwater. This information came from Erin Poor, a hydrologist with USGS, and she was looking at the beaver of the Tualatin Basin in Fanno Creek here in Portland. I think a lot of people are familiar with this. The beavers showed up, they made a beautiful mess. If there's one thing I hope everybody can get from this talk, it's that beaver make a beautiful mess. They flooded out this site, they flooded the trails, but what benefits are we getting from these beaver in regard to stormwater? Well, we're getting the same thing we would get in wildland settings. We're seeing reduction in peak flows, reduction in suspended sediment. That sediment is being stored on the landscape, and we're also seeing some temperature complexity. Let's take a closer look. Here are some hydrographs from Fanno Creek, and we can see that in each case, the red line, which are the downstream gauges, have lower peaks than the green-blue lines, which are the upstream gauges. So we are seeing flow attenuation, we're seeing peak flow reductions. How about Stoller Creek down below? This is another creek nearby Fanno Creek, and here it's a slightly different story. On the right, we are seeing modest reductions in peak flows. However, on the left, we are not really seeing any reductions, and actually in one case, we have higher peak flows below the beaver activity. So I think this is a good reminder that beaver are not going to be right everywhere. They're not always going to be the right choice, and sometimes we will have to make decisions such as lethal management or moving these beaver on the landscape. All right, so we are seeing flow attenuation. How about sediment removal? At Fanno Creek, they found that suspended sediment here on the Y and samples on the X, the green diamonds are the upstream gauges and the squares are the downstream samples, and we find that indeed the downstream samples have less suspended sediments in them than upstream. So some of that sediment is being stored somewhere in that beaver activity. That is supported by this turbidity graph. Turbidity is a measure of how much sediment is in that water column, and here we see that all of the turbidity samples are lower than the upstream samples. Where did that sediment go? It was stored in the pond. There was around 1,200 cubic meters of sediment stored in that pond. So it's looking good for flow and sediment with these few cases. How about water quality? This is out in Gresham of Portland again, and this is the Columbia Slough Regional Water Quality Facility. It was constructed in 2008. It treats around 1,000 acres of industrial and commercial stormwater and runoff. It costs around $2.4 million, and the beavers thought this was a great idea. They showed up and they set up shop. They built significant dams and immediately started to alter the hydrology and the geomorphology and the function of this site. So was this site doing better with beaver or without? In terms of water quality, with no beaver dams present, we saw that this site was doing a decent job removing heavy metals. It wasn't doing such a good job removing nitrogen, phosphorus, and sediment. How does that compare to when we had beaver dams in this site? Well, now we see that beaver dams actually helped remove even more of those heavy metals. Now, in addition, we're also removing nitrogen, phosphorus, and sediment, whereas we were adding that to the system before there was beaver here. And we're also seeing more removal of pesticides. The water is essentially a little cleaner moving through this system with beavers present. I should also mention, excuse me, this information comes from Katie Holzer of the city of Gresham. So how about temperature? The Johnson Creek watershed in Portland has anadromous fish populations throughout it. It's well known to flood and also exceed temperature limits. Throughout this watershed, several human concrete check dams have been built. These dams are concrete structures that are meant to only activate during high flows. We also have several naturally occurring beaver dams, and we can compare these structures to see how they impact temperature of this system. The above graphs show 3 human dams. The blue line are temperature upstream of the pond. The orange line is temperature downstream of the pond, and our red line is our exceedance at 18 degrees Celsius. We can see in all cases that the water is cooler upstream of that concrete dam in the pond than it is downstream of the dam. How about the beaver dams? Well, that's a different story. The beaver dams, both A and B, there is almost zero difference in temperature upstream versus downstream of that dam. And in case of Dam C, we see that the water is actually cooler downstream of the dam. So why might this be? Well, it's probably because the beaver dams are porous, and the porosity of that dam allows for water to seep through, drawing water from all levels of the stratified pond water column. It's drawing water from the top warm parts of the pond, but also the cool, deeper regions of the pond. In addition, the hydraulic head of the beaver pond forces water into the subsurface, where it is then cooled, moves downstream, and then it may reemerge with the surface water further downstream. So we see an increase in hyporheic exchange and an increase of mixing. In Johnson Creek, we saw 0 temperature exceedances in the beaver modified streams, but with those human dams, we saw almost over 50 temperature exceedances. All right, so these are very small sample sizes, but we don't have a lot of research about how beaver are impacting our urban environments. So any data we can get is very useful. Thank you so much, Aaron Poor and Katie Holzer, for sharing that with everybody. Now, so the beaver are present, they're useful in managing stormwater. Now we have to manage these beaver population. Well, traditionally urban beaver management was very simple. It was just lethal removal. But now we want to try to coexist with these animals. And we have tools available to us that we can use that will allow coexistence. In regard to chewing vegetation, fencing and abrasive paints have been known to be very effective. In regard to flooding, culvert protective fencing and flexible pond levelers are used. Now, unfortunately, due to time constraints, we don't have a lot of time to go over these in great detail. So please, if you would like to discuss these further, let me know. I'm happy to do that. But just to go through them quickly, in regard to fencing, this fencing works. If you install it correctly, it's going to work almost 100% of the time. And that's what this graph shows. The only thing that worked 100% of the time was the fencing. I don't have a lot of experience with the abrasive paints, but some people can find some moderate success with the abrasive paints. Culverts are the favorites of beaver to plug. Beaver love to dam up culverts. It's because they can expend a relatively small amount of energy, build a really small dam, but pond a significant amount of area. Culvert protective fencing comes in all flavors and sizes. The trapezoidal form is one of the most common, and I'm happy to explain why that is. But in regard to ponds, flexible pond levelers can be very effective. Flexible pond levelers are great because they will prevent the pond elevation or the pond surface from rising above a certain elevation. This is really important because the pond and the dam are what we want to remain on the landscape so we can receive the ecosystem services and benefits from those structures and from it's not just the beavers, but it's the pond and the dams that we want that are giving us those ecosystem services. So by using fencing and using pond levelers, we allow those features to stay in the landscape, but we prevent them from flooding the adjacent infrastructure. Culvert protective fencing can also be combined with pond levelers, so you can use both in unison. And when it comes to culverts, typically it's just that the culvert is too small. If you have the ability to put in a larger culvert or a bridge, that is going to dramatically reduce the ability of beaver to dam that structure. So I've mentioned that they work in Connecticut and Massachusetts. They looked at over hundreds of these structures, and up to 97% of them were successful. They're not only successful, but they are also cost effective. The Department of Transportation in Virginia switched to non-lethal management, and they ended up saving around $250,000 a year. So some key considerations: beavers are in our urban areas and they're there to stay. So now that we're trying to use non-lethal management and coexistent, we have tools available to us and they're going to work. And it's important to try to coexist with beaver because benefits of having urban beaver populations go far beyond just stormwater. And then another key thing to remember here, again, beaver are not right in every situation. Lethal management is always a tool, and we're not always going to allow the beavers to stay. Okay, so we investigated this first track. Now, what's the next step? And the next step in my mind is actually designing these facilities and designing restoration projects to anticipate beaver to be a part of that system. So we can look at this conceptual diagram I put together and use it to look at a couple case studies up in Seattle of just that. These designers had beaver in mind when they started these projects. I just like to say that a lot of these ideas, this conceptual model was modified from ideas that Bailey and others, 2018, came up with in their paper about using beaver in urban design. These case studies we're going to look at also came from that paper. So starting at the top, we kind of already went through this scenario, and essentially it's human design that wasn't meant for beaver. And so when beavers show up, they start to remove vegetation and they flood, and we lose function of those sites. Then our response is usually to kill them, but now we're thinking about coexisting with the beaver. In that case, the beavers will continue to damage these sites until eventually we realize we have to redesign these sites, either by putting in pond levelers or actually completely redesigning the whole system. We can take this a step further and think about now designing, anticipating beaver to show up out of these sites. And in that case, when the beaver do come, instead of damage, we are now going to see benefits from those beaver. We're going to see benefits to stormwater, also increased function of these projects. And our response will be to then manage them non-lethally, allowing the beavers to reach carrying capacity. And in the end, these projects, hopefully, we will be receiving moderate ecosystem services from them. One example is the Magnuson Park wetland up in Seattle. This was a very large site, around 150 acres, designed to capture stormwater and runoff from the surrounding neighborhood. Its main goals and objectives were to create wetland habitat and increase amphibian and avian populations. They had a couple cool features. They built some vernal pools in the top part of the site that are meant to capture runoff and dry during the summer months to create amphibian habitat. In anticipation of beaver showing up, they built some earthen weirs to initiate the flooding process, jumpstart the transformation of this site with the hope that beaver will show up and continue that process. Well, the beaver sure did show up, and they immediately started flooding this site. As you can see with the red line, by extending the flooding by up to 30%, so much so that it started to flood out those vernal pools, creating perennially flooded sites at the top of this site. So this was a concern because they thought it was going to hurt the amphibian numbers. But the managers came in, they adaptively managed this site. They put in some pond levelers to control the flooding. They put in some signage for the public, and they re-engineered a pivotal pinch point, hoping that beavers would take advantage of that pinch point and build dams in that area to encourage flooding in that particular part of the site. In the end, they're really happy with the beaver being there. The public seems to be very happy and behind this project, and the numbers are way up for amphibians and birds. So they're extremely happy. The amphibian and avian numbers are higher with the beavers there than they were without the beavers. So I think if we want to take this to the final step, it would be to actually design these sites to not be fully functional until beaver have got there. So not just anticipating the beaver to show up, but we need the beaver to show up. And I would just like to mention that as we progress down this chart, we are not only increasing in functionality or the level of ecosystem services we're going to receive, but we're also decreasing in project cost. That's because the beavers are doing most of the heavy lifting. So here we can look at the Thornton Creek Confluence and Meadowbrook Pond up in Seattle. This site, as I mentioned, was designed with beaver in mind, knowing that they're going to come to this site. Some key features are on this road crossing, instead of putting in a culvert, they put in an aerial floodplain connecting bridge so that beaver wouldn't have the ability to plug that culvert. In addition, they constructed very large floodplains with the anticipation that beavers would come and flood this area, connecting these floodplains hydrologically to the stream. They also planted some native vegetation for the beavers to harvest, and they included several large engineered woody structures especially at constriction points of the stream, hoping to take advantage of the beaver behavior of wanting to anchor dams to large woody debris of streams. Some concerns the designers had at this site were that the beaver would show up too early, actually, and start to remove the vegetation before it had a chance to establish. This is a very common problem with restoration projects, and some solutions are you could put up some fencing around that vegetation. You could also bring pre-cut vegetation to the site and offer that to the beavers, hoping that they'll take that before they take the planted vegetation. At this site, there was some flooding already because the water table was high enough to support that vegetation, but in the end, this site won't be fully functional until the beaver come and fully flood the floodplain and activate it to the stream channel. Okay. In regard to designing with beaver in the future, I think Beaver Dam Analogs are a really exciting tool that can be used. Unfortunately, we don't have a lot of time, so I'm just going to briefly mention that I think these could be a future potential tool, especially in urban areas where we're limited on space. And when beaver come to these urban sites, we hope that they'll build dams in certain areas, and often they will just build them somewhere else. So with Beaver Dam Analogs, as I mentioned before, they mimic a naturally occurring beaver dam in both form and function. So as soon as you put them in, they are immediately storing water and storing sediment behind them. So in urban areas, you can place these analogs exactly where you want them. The hope generally will be that beaver will come and show up and then take over maintenance of these structures and actually improve them. Urban areas were often constrained in space, and often urban streams are incised as well. Incised streams have very strong stream power, so sometimes it's hard for beaver to establish in these reaches. Again, Beaver Dam Analogs were actually designed initially to be used in incised streams so that they can withstand those stronger flows, and over time they can start to collect sediment behind the Beaver Dam Analogs and eventually even upgrade these incised streams, raising the elevation of the stream bed. Unfortunately, we don't have more time to talk about them. This is a whole talk in itself. All right, some key takeaways. In urban areas, one of the major constraints is space. There's just not enough space for the beaver to expand their sites like they want to. So we can use tools such as pond levelers to allow them to stay and just utilize the space that's available. Beaver are attracted to pinch points. We need to plan for fluctuating water levels, and adaptive management is always going to be key in regard to managing beaver and using beaver in design. And again, key point, beaver are not right everywhere. They're not always going to be acceptable. But hopefully, as we see in this graph here, we can start to use ecosystem engineers to get our projects into our target zone of either, if it's a restoration project, we can get them to this target zone of restoration faster than it would be if we were not using ecosystem engineers. All right, well, we're out of time. I have some Beaver resources here that I think could be useful for everyone. I also have literature cited that I talked about in this talk. So if you're interested, just let me know. I'm happy to share that, and I'll leave it here in the Beaver resources for everybody to take a look. I'm happy to take questions. Thank you very much.
Thank you, Greg. I think we're all kind of clapping and cheering. You did a great job. I first wanted to let you know that there was a number of people in the chat box that gave you some shout outs and also thanking you for showing their work and presenting on the work that they have done. So I just wanted to pass that along to you. So we're going to take a couple of minutes to do a couple of questions, and then we'll do a break at 7, and then maybe stay on a little past 7 if people are interested in asking some more questions. So I'm going to get started on a couple of questions. So the first one, Greg, for you, I'm going to start you off easy. Where can people go to learn more? And how can the public as like individuals help?
Yeah, so that's a great question. You know, I think where we can go to learn more about beaver, some of the best places are try to go find beaver out in the wild. This can be very difficult, but like I said, there's more and more urban beaver. So sometimes you don't have to go very far to encounter beaver populations. There's also a lot of great resources online right now, and that's a really great place for people to start, I think, and gather information. There's a lot of organizations out there, the Beaver Coalition, Martinez Beavers Worth a Dam, Cows and Fish, Beaver Northwest. All of these outfits are out there working on using beaver on the landscape and protecting beaver. And then there's some publications as well. The Beaver Restoration Guidebook is a great place to investigate beaver, using beavers in restoration. Yeah, I think those are some of the great places to start looking or learning more about these beavers. And what was the second part of the question?
What are some things that maybe some individuals can do on their property or just in general to help beavers? And yeah.
That's great. Yeah. Right now in Oregon and Washington, if a beaver shows up on public or on private property, you don't need a depredation permit to remove it or to kill it. But what I would recommend is, instead of, if a beaver is causing problems, if you cannot immediately remove it, but talk to people who are transporting beaver from problem areas to other areas where they can thrive. That would be the first step. Also, just allowing beaver to stay in certain areas where we haven't let them stay before, we can receive a lot of benefits from just allowing beaver to be in our backyards. Another thing we can do is just talk to our neighbors. Find out if our neighbors have beaver on their property, find out if they're thinking about allowing the beaver to stay, and again, accessing these resources, using pond levelers and fencing, using these tools to allow the beaver to stay on your property without causing a lot of damage.
I'm sorry, I'm laughing. Somebody just asked, where can I get one, like a beaver as a pet?
They
No,
don't make good pets.
they're wild. Stay in the wild. Several people ask questions around salmon and beavers, and mainly thinking about their dams and how salmon are able to or not able to move through their dams, and how maybe if you can speak to a little bit about how salmon or how beavers help salmon, and if salmon are able to move through their dams or if they're blocked by them.
Yeah, so this is a great question. And it's a concern that a lot of people have had in the past and still have today. And the concern is that exactly what you said, that beaver dams are perhaps blocking the migration of salmon in our streams. Well, the reality is that beaver and salmon have co-evolved together for millions of years in these streams. And before humans showed up, the salmon populations were larger than they've ever been since we showed up and started manipulating this environment. So the beavers and salmon have figured out how to get along long before we showed up. And the reality is that salmon time their migrations when there are larger flows happening in the streams. And when in a stream with a lot of beaver dams in it, during these large flows, the ponds fill up to capacity. They start to overflow over the dam face, but also around the dam, creating a lot of pathways for the salmon to move up and around the dams. Beaver ponds also create that variation in depth we were looking at. So below a dam, there'll often be a plunge pool, which is deep water for the salmon to actually jump over the beaver dam. Salmon are incredible jumpers, so they can jump over pretty tall beaver dam structures. So I think we need to realize that beavers are not only not impeding the salmon, but they're actually creating habitat for the salmon. Salmon populations are really affected by the upland habitat in our watersheds, because that's where salmon are rearing after they spawn. And where do salmon want to rear? Well, they want to rear in slow water habitat. That's what beavers create. They create ponds and off-channel slow water habitat. So the beaver ponds are where those salmon want to hang out during the winter and grow big and strong before they head out to the ocean. So beaver are actually really important for salmon, and we need to continue researching how beaver affect temperature and how they affect migration so that we can increase our confidence even more that beaver and salmon are actually great partners.
Awesome, thank you. So I'm gonna go to this question. I'm reading Ben Goldfraub's Eager Beaver, and he makes many compelling arguments for living with beavers. If you've read this book, what do you think, and what do you think of his work?
Yeah, I think Ben Goldfraub's work is great. I've had a chance to chat with him briefly, and I think his book is great. I actually haven't read the entire thing, to be honest, but what I read, it was right on, and I'm just really happy that he's able to put that kind of work out there, because the more information that we can get out about beaver, about their story, their legacy in the past, and how that continues today, how we receive so many benefits from beaver, and also all of the animals that beaver support. So all that sort of information, books by Ben, great job. Keep up the good work. I think that is wonderful.
Awesome. So it is 7 o'clock, and I do want to be respectful of people's time. And Greg, are you willing to stay on for a little bit longer to answer a couple more questions?
Definitely.
Great. Well, I do want to say, to be respectful of people's time, feel free to head out for the evening. We're going to stick around and answer a couple more questions. And then the recording for this video is online. And also please fill out that survey and let us know how we did, and let us know. Feel free to reach out to Greg or myself to let us know if you have any other follow-up questions. So with that, let's ask a couple more questions. So I know tonight we've been talking a lot about like urban situations, but this one's kind of fun to think about more of livestock and rangeland areas. So can beavers successfully coexist with livestock on rangelands? I've seen many instances of grazed riparian areas that could potentially support beavers, but there aren't beavers there. Do you know any research on that?
Yeah, that's a great question. There's a wonderful outfit up in Canada called Cows and Fish. I actually poached a lot of their great pictures and illustrations from a document they published called Beaver, Our Watershed Partner, for this talk. And like their name suggests, Cows and Fish, they're kind of all about figuring out ways for animals to coexist together, maybe animals that we didn't think would work well together, such as cows and fish and beaver. And what they've been able to show, and other research, is that rangeland, there is a place for beaver on rangeland. Often the beaver and the cattle will begin competing for that riparian vegetation. So we do have to work on limiting the access to that vegetation in certain situations so that there's enough for both. And also in rangeland streams, we find that in the past, when ranchers first showed up to some of these streams in the West especially, they were perennially flowing streams and they were full of beaver. The beaver were then removed, and they find now today that those streams are no longer perennially flowing. And so cattle require a lot of water, and they end up spending a lot of money on water for their cattle, but also on supplemental feed for their cattle, because the amount of pasture and grass that is growing on their property is also reduced now that those streams are no longer perennial. Well, in some cases, when the beavers show back up to these streams, we see them return to perennially flowing systems. And in some cases, I've heard that some ranchers that were harvesting hay on their property, once the beaver came back, they were getting double the amount of hay off of their land that they were when there were no beavers present. And that's primarily because of the extra water that was stored and available for that hay and later dry months. So I think there is definitely room for beaver and cattle to coexist. And there's lots of different grazing techniques that we can use so that riparian vegetation is saved and that there's enough for both species. But there needs to be more research on this. It's a great question. Definitely check out Cows and Fish. They have some good information on that. And yeah, there's definitely room for both to coexist.
Awesome. So there's kind of been a couple of questions related to like removal of dams and like why people remove dams, and why maybe like Oregon and Washington might be focusing on removing of dams in some areas. Can you speak to that?
Yeah, so it's nothing new. Beaver dams have been being removed from our streams for a long time. They're removed for several reasons. Sometimes they're removed in the name of fish passage. Sometimes they're removed in the name of temperature. And I hope I showed that with some of this research, we're seeing that beavers are actually beneficial to stream temperatures in a lot of cases. And in regard to fish, beaver and fish are great partners. So hopefully we're learning that we shouldn't be removing the beaver dams for either of those reasons. Also, beaver dams are removed just to stop the flooding. And when a beaver shows up and floods out our shed or our barn, nobody wants that. So there's ways to prevent that. The pond levelers are great tools. We don't always need to completely remove the dam. And in fact, now with beaver populations increasing and on the rise as they are, it's not really effective just to remove the dams, because you remove that dam, the beaver may still be there. Even if you remove the beaver, that has opened up that niche for another beaver to just move in and fill that. And that's exactly what's going to happen. So you're not just removing one dam, you're going to be perpetually removing those dams over and over again. And it's a common thing. We've removed a lot of things from our streams. In the past, we used to remove large woody debris from our streams in the name of migration and fish. We realized that was a mistake. Now we're putting wood back into our streams. And that's the same thing that's happening now. We're starting to understand more the role that beavers play in our stream ecosystems, and we're starting to realize that perhaps it's good to have the dams in our streams. They act as longitudinal impediments, and it's healthy to have increased complexity in our streams. So we're starting to see a shift in the ideas and behaviors about what should be in our streams. And I think that's what's going to happen and continue to happen with beaver dams. As we learn more, hopefully we'll stop removing those dams. I'd just like to say, if you are going to modify a beaver dam in any way in the state of Washington, you have to have a permit, including putting in a pond leveler. So the website for the permit is right there on the page, just to let everybody know.
Awesome. I'm going to kind of blend two questions together. Somebody said they've, in urban sites, have seen lots of burrows with few dams, and do the burrows allow and provide lots of benefits? And then I also saw a question asking about nutria versus beavers burrowing into the side of the banks, and if beavers did that, if only nutria did that, and if maybe you could speak to both of that.
Yeah, those are both great questions. Yeah, so beaver will often not build dams, but they'll have extensive burrow networks in streams. And these burrows do actually create great habitat for other species. There was some research that came out of Northern California, I believe, it might have been in the Shasta region, showing that in a stream with salmon, when they did a scuba or a snorkel survey, they found most of the salmon congregating around these beaver burrow entrances, because in some reaches of stream where there's not a lot of woody debris or it's high velocities, those burrows act as slow water refugia. So there can be a lot of animals that access those burrow entrances, not just beaver. So even if beaver aren't building dams, dams are really the thing that provide the most benefits for us. But we need to realize that even non-dam building beaver populations are still providing benefits for us, like having burrow entrances in the stream. In regard to nutria, beaver and nutria are now competing with each other for both resources and habitat. They're both eating the same thing, and it's unclear right now who has the upper hand. I've heard stories of nutria being more aggressive than beaver and forcing some beaver out of areas, but nutria are a huge problem. They're an invasive species, and so there's a lot of money spent managing nutria, and unfortunately, we're going to be dealing with nutria for a long time into the future. So yeah, beaver and nutria are not best buds right now.
Okay, I'm gonna ask one more question and then hopefully have a little fun surprise. There's been a couple of questions about relocations of beaver. I know you talked a little bit about it. Some questions like, what is the success rate of beaver location? Hearing stuff about how family units need to be relocated together to have the best success. And then also there's been a couple of questions about seeing relocation happening and whether or not, like, you know, what's going on there and why people choose to relocate. And then I'm just gonna make this a three-parter question. If you are relocating, if you kind of see like an area that they're damming, is it good to relocate them up or downstream to help kind of spread them out especially like an urban stream population?
Okay, yeah. Well, in regard to urban streams, you cannot relocate beaver to any urban streams at all. You're not allowed to relocate beaver within any urban centers. So yeah, you can't do that. But in regard to translocations of beaver, this is happening because people are finding beavers as they're a nuisance in certain areas, and instead of killing them, they want to move them somewhere else. And this is a great idea, right? It's tragic to lose any beaver, so if we can put them somewhere else where they can do some good, that's a great thing. It just turns out that translocations are incredibly difficult. Initial translocation mortality rates were extremely high. So in a lot of cases, we were taking a beaver from one site, ripping it away from its family, and then taking it somewhere else, dropping it off in degraded habitat where it's exposed to the elements, and it would either just flee the site immediately or it would die from either exposure or predation. So there's now a lot of outfits out there that are working on translocating beaver. The Methow Beaver Project is one. I had the chance to go up there for a week-long workshop where we saw how Kent Woodruff was relocating beaver. And what they've done is they realized you need to create a site that you can take the beaver to, hold them there, bring in, allow you to catch the entire family so that you're moving entire beaver families to new sites altogether. In addition, you really need to pick your release sites very carefully. And if they're degraded, you need to help those beaver out with either food and construction material or housing to ensure that the beavers have something to get started with. So in regard to translocations, I would just say that you need to be very cautious. The permits are very hard to get because you have to do so much work on the release site and making sure that everybody's happy with the beaver relocation in that area. I would really leave it to the professionals. Methow Beaver Project, there's other outfits up in Washington that are moving beaver around in the world. And those are the guys you want to call if you have nuisance beaver and you're thinking about trying to have it removed off your property. It's very tricky. We're still learning how to do it right, but I think in the future, we're going to have even more success with it because we shouldn't just be killing the beaver. If it takes a little bit more work to move them on the landscape, let's do it. But it definitely takes a lot of pre-planning and thought to do it correctly.
Thanks, Greg. And with that, I'm gonna turn it over to somebody else to give the last word. So hopefully I did this correct. Joe, are you there?
I am there. Can you hear me? Do you hear me?
Yes, we can hear you. So what is your question or comment?
My question, first of all, you're doing a great job in this presentation. And if I was still teaching my wetlands course, I would have you, if I could pay for you to get back down PSU, I'd have you teach a section or two about beavers. But I'm not. I'm retired completely, somewhat. At any rate, my last question is: how are you in your? How are you doing in your PhD work? Are you done or close to being done, and what kind of jobs are you looking for?
Wow, Dr. Mazur, it's wonderful to hear from you, the legend. That's amazing. Thank you so much for that compliment. And yeah, the PhD, I'm in the process of writing the dissertation, so I'm in the writing phase. You know, due to some the COVID and everything, there's been a lot of roadblocks, so it's slowed down the process a lot. But I'm still hoping to finish that up. And right now, actually, thank you for asking because I'm currently looking for employment, and if there's anybody out there that knows of any positions that are looking for people with a lot of knowledge about beaver and restoration and watersheds, please let me know because yeah, I'm looking for work. But Dr. Mazur, thank you for that compliment. It's wonderful to hear from you, and what a surprise. Thank you so much for joining today.
For all of you that don't know, that is Joe Mazur, who was Greg and I's master advisor. So thank you so much, Joe, for that last fun question and just wrapping it back up to kind of hear how Greg's doing. So thank you, everybody, for joining us this evening. We are really excited that you were able to spend this little over an hour with us, and make sure to fill out the survey at the end of the presentation, or if you're watching the recording, it's in the link down below, or the links down below. And thank you so much and have a lovely evening. Goodbye.
Thanks, Ashley.